In this video, we're going to learn about some topics in thermal physics. This is topic 3 in the IB physics course, SL. And we're going to look at the difference between solids, liquids, and gases. And I know what you're thinking. You're thinking, gee, I sure spent a lot of time in grade school learning that. And I then went on to chemistry, and I learned it from a chemical perspective, chemistry perspective. So why are we doing this again? Well, we are going to take another lens. We're going to approach this differently from how you've done it in the past. We are going to look at the molecules of the solids, the molecules of liquids, and the molecules of gases. And we're going to compare their kinetic energies, and we're going to compare their potential energies. So that's the perspective we're taking. It's a physics perspective. Now, in case you've forgotten or need a refresher, solids, liquids, and gases, these are the three main phases of matter, which we also can call the main states of matter. And these two terms we will be using interchangeably. What are phases or states of matter? They're descriptions of the different ways that we find matter organized and structured in the universe. So sometimes it's structured as a solid, which means certain things, sometimes liquid, sometimes as a gas. There are, in fact, two other states that we're not really going to look at, two other phases. Plasma is another one. That's the phase of things that are really hot, when they're super hot, even hotter than gases. And then there's another one, which is the phase of objects that are super cold, and those are called Bose-Einstein condensates. BEC, Bose-Einstein condensates. Those are really cool. You should study those in your college physics class. So let's get started. The very first thing that we're going to do is, whenever you hear me talk about the stuff that makes up a solid, or the stuff that makes up a liquid, or the stuff that makes up a gas, I'll always use the term molecules. Now I know what you're thinking. You're thinking to yourself, in chemistry class, we learned that molecules aren't the only stuff that makes up our substances. Sometimes we have ionic compounds, which are different. And other times we have just single atoms making up the stuff. Well, you're right, that's true, but we're going to ignore it, and in this class, we're not going to ever use the term ionic compounds or atoms. When we're talking about the stuff making up solids, liquids, and gases, we'll always use the term molecules. So this is a simplification, and that's okay, because we can keep these subtleties when we learn chemistry, when we do chemistry, but for physics purposes, it's okay to simplify, and we're just going to use molecules, our good old friend, which will become very familiar to us. So the first on our list will be solids. Here's a picture I want you to draw of how the molecules in a solid are arranged. They are very organized, and I'm going to represent the organization by making a box of molecules. So there's a lot of structure. They are connected, right? We could even draw little arrows or lines to show the connections, the bonds. And let's mention some things about the solid. The first note is that the separation distance between molecules, there it is, that term molecules, it's fixed and it's small. So the separation distance, that would be represented by d here that I've drawn in. And this distance d is relatively fixed for solids, and it's also a small distance compared to the other phases. The next point is that these molecules have a limited range of motion. We're going to explain what that means. Here's what it means. The molecules are composed of little atoms, and those atoms can vibrate back and forth. So if you imagine that each molecule is kind of like two styrofoam balls attached by a spring, if you stretch the spring out by pulling on the molecules, and then you let go, then they'll sort of vibrate back and forth. That's the kind of vibrational motion that these molecules can undergo. So we represent it here in our picture by putting little wiggly lines, right? They're wiggling, they're vibrating back and forth while staying in the same fixed position relative to other molecules. So let's put that down. Vibration is one of the ways these things move. Another way that these move is they can rotate. So they can actually kind of flip around like this. And this one flips like that. They flip around. So vibration and rotation are the ways that they move. And of course, they stay a relatively fixed distance apart. Now, because they are so limited in their range of motion and the ways they move, they have small speeds, these molecules. Okay then, time to figure out then what this means for potential and kinetic energy. These molecules are attracted to each other, right? This molecule and this molecule, they're attracted, so are these two. And that attraction is what binds them together. Now, when two things are attracted but separated by some distance, d, they have potential energy. Just like how, if I lift a ball off the ground, it has potential energy due to its attraction with the ground, the gravitational attraction. So here, we could say PE is small. And the reason it's small is because the separation distances are small. Now, the kinetic energy is also small. And the reason for this is because there's limited range of motion, so there's not a lot of different ways that this thing can have kinetic energy, and the molecules have small speeds. So we've written some things down here, and it's important to understand that this bullet is responsible for the small potential energy of our molecules in a solid. These two bullets are responsible for the small Ke, kinetic energy, of the molecules in our solid. Okay, so next on our list is liquids, and this should be a little faster than the solids. Here's the picture we draw for liquids. We have molecules. They're a little bit more spaced out than the molecules of the solid. Here are the bonds. The separation distance between molecules is still roughly fixed and medium in size. So these molecules for our liquid are separated by a slightly larger distance. They also have fewer bonds to neighboring molecules, which provides them with a medium range of motion. And what we mean is, well, they can vibrate back and forth, just like we saw with solids. They can rotate, like we saw before. But these molecules can also move translationally. They can undergo translational movement. And what that means is that they can move up, down, left, right, back, forth. They can move along the X, Y, and Z axes. That's what translational motion means. So let's write that down in our notes. They can vibrate, right? They have vibration. They have rotation, they rotate. And they have translational motion. Translational. Now and so let me say, that translational motion, the fact that they move up and down, is the reason why a liquid meets the shape, it changes its shape to the container it's in. So if you put a liquid in a glass, it'll look like this, it'll fill up the glass. But if you put it in a bowl, it'll spread out to fill the bowl, because those molecules can move up, down, they can move left, right. On the other hand, if you put a solid in a glass, like a rock, and then you put it in a bowl, it stays as a rock. It keeps its shape because those molecules can't move left, right, or up, down. Now, because we have a greater range of motion in these liquids, that is one of the things that allows them to move faster. So they have medium speeds. The molecules of liquid have medium speeds. Okay. And when I talk about speed, I'm talking about the molecules' speed, not the speed of the liquid, right? I could throw a ball at a higher speed than I could throw a jug of water. But the jug of water still has faster moving molecules inside that water than the ball has inside the solid. Okay, medium speeds. We're now ready to look at kinetic and potential energy. Because of the medium separation distance, the potential energy is medium in amount compared to the other phases. The kinetic energy is also medium in its amount because of the medium speeds. So the same relationship exists here as it did before. The medium separation distance is responsible for the medium potential energy. The medium range of motion and the medium speeds are responsible for the medium kinetic energy. And let me point this out again. The farther apart the molecules are from each other, the farther they can accelerate back toward each other. And so, the potential energy is greater as the distance between molecules gets bigger. So if you pull those molecules farther apart, they now have greater potential energy, just as a ball has greater potential energy when you raise it higher off the ground. We've come to the last on our list, gases. Gases look very different from solids or liquids. So here's how I've drawn my gas. Now, the first notable thing about gases is that they are flying around in all random directions. So the different molecules are all going in different directions. They're moving around totally randomly. And that means the distance, so what I'm saying here is that the distance between two molecules changes. These molecules can come toward each other, they can collide, and then they can bounce off each other, so that the distance between them, separating them, changes drastically as they move closer and then apart. But on average, the separation distance, so first let's say the separation distance is not fixed, it's variable, and that's different from liquids and solids. So it's a variable separation distance, and the separation distance is huge on average, because sometimes they collide and they get really close. But on average, they are very far apart distance. Now, what about their range of motion? They have the greatest range of motion. And what we mean is, you guessed it, they can vibrate just like the others have been able to. These molecules can rotate while they're flying around, and they can move translationally. They can move in the X, Y, Z directions. So let's write that. Vibration, rotation, translation. The difference in their range of motion is that these gas molecules are unconfined. They are not limited or confined to a fixed separation distance. So let's write and unconfined. Okay, all right. Now, because of their great range of motion, this is one of the things that contributes to their really high speeds. These gas molecules are moving the fastest. They have the highest speeds. So how about potential and kinetic energy? Because their separation distance is huge, the potential energy is biggest for gases as compared to the others, liquid solids. Because they have so much range of motion and because they're moving so fast at high speeds, Ke is also biggest. The relationship from before is still applicable. The big separation distance is responsible for the big potential energy, and the big range of motion and the high speeds are responsible for the big kinetic energy. So what that means is these gas molecules can have rotational kinetic energy, like this. They can have vibrational kinetic energy, and they can have translational kinetic energy. And those values can get higher because of their high speeds. So that means they will have, on the whole, greater kinetic energy than, say, a solid, which doesn't have access to these translational kinetic energies. Okay, the last thing I want you to do is make a chart comparing gases, liquids, and solids and summarizing all of the information from the video. I've given you an example of what this could look like, but please, by all means, do it in a way that makes sense to you. This is not necessarily the best way to organize it, this example that I've shown. You could probably find better ways, and I encourage you to do it a better way. Do it the way that makes most sense to you, because then you'll remember it better. Now, things to include: separation distance. You want to make sure that you include somewhere whether it's a fixed or variable distance between the molecules. And then you would also want to rank them, the separation distances for the three states of matter. Rotation, translation, vibration, you could just have a yes, no for whether that is one of the ways that the molecules move in a gas, liquid, solid. Speed, you could rank Ke and Pe. You can just rank. So this is part of the homework. The rest of the homework is to take the quiz. After you've completed the chart, take a quiz, and it will quiz you on what we've just learned in the video. And I encourage you, do your chart without any notes, without any help. Do it just from memory. And then do the video without any notes, without any help, and just from memory. If you try and do it from memory and quiz yourself, in that way, then you'll remember it better and you'll learn it better.